So here I've got two types of display. On the left, a traditional display where content is shown on a flat screen composed of digital pixels. On the right-hand side, we've got a new type of display where we've got levitating objects held in midair by ultrasound. By manipulating the sound field from this device, we can move these elements around and change the appearance of the content, the same way we can change the appearance of pixels on a screen. So the advantage of using a levitating display is that you can have true 3D content. So here, for example, we've got several objects laid out in a square, and depending on the angle that you look at it from, you can get a better understanding of the physical properties of this object. You could see straight through the display because the pixels are held in midair. So for example, you could have a group of people all looking at the content, but they can also look up and see each other at the same time. If you were to do this with a traditional laptop screen, you know, that's going to get in the way if there are people. So this could encourage better collaboration. So the way I see the future of this technology is increasing the scale. So, you know, as we get a better understanding of how to manipulate the sound fields, we could levitate more objects, we could move them in more interesting ways, we could also potentially change the size, the shape, the appearance of the objects as well.
So the objective is to create a whole new way of interacting with technology. So by creating 3D objects which can rise up in front of you in space with each individual pixel as a levitating particle, we can then use tactile feedback so that you can feel virtual objects on your hands without having to touch or hold anything. You can just put your hand out and feel those objects. So the objects are suspended in the air using sound pressure waves. You can see an image representing that on the computer here. So we can hold those particles in space very stably, then we can move them around, we can hold multiple particles, then you can imagine creating a whole 3D surface of small particles which we can then dynamically change as required. For example, if I was working on making a model of a car, instead of having to carve something out of clay, I could have that model created in front of me with multiple little pixels in space marking out the surface of the car. Then I can interact with that. For example, I could do a gesture to change the way the headlights were if I wanted to change the design. Or I can change different kind of objects. I could have an object raised which looked like a dog. I could change that with a button press to be like a cat. I can move it around in space. It could spin around.
Perfect.
When a user is trying to touch an object in the virtual reality, what we can do is we can make the user feel different. For example, papers. A smooth paper tends to have smaller, wider edges. Therefore, it can make a much smoother feeling, a less intense feeling. But with ultrasound, we can make it even more. We can make different papers that are much rougher, for example, feel more intense and more powerful. Now I'm touching a rough paper. This is intense and powerful to the hand. A user can distinguish. If we go even further back and we go to this texture, as you can see, it's much softer. This produces less impact on the hand, and the edges are much smoother. Therefore, the user can distinguish between smooth and rough.